And then I
OK， 就像你用的教程是这些都可以。
Oh no. Okay. How do I get this on my screen? Is it settings to mirror the screens? Settings, display. Mirror. Okay, wait. Why is it my?
Oh. And then present that one. Yeah. I think you should be good.
Okay, this should be fine.
Yeah, you can just once you go off that screen, it will show whatever you show.
Okay.
And just we have to remember to stop at the end.
Okay, cool. Okay, can I stop?
Yeah.
Okay, so I'm just gonna give like a quick tutorial on Neon, which is the deep learning framework by Nervana Systems. So just to start with, this is the open source, this is their GitHub link. Those are the benchmarks if you want to take a look, and that's the getting started guide link, which is what I'm going to be going through mostly, and it's pretty good because I wrote most of the documentation.
So were you the first intern or something?
I was like the first person to really use it.
Wow.
Okay? So,
how did you find them? Like, if it's so new.
Like I had just Googled like machine learning internship San Diego.
That's awesome.
And then so they've only been around a year, but it's getting like pretty good.
Cool.
Yeah. So installation, it's pretty straightforward. So on CPU, they'll like, it's like average performance, but they're really good on GPU. So they just, that's just the way you set up GPU. You just have to go to get the Maxwell assembler. They have a specific one.
What's Maxwell?
It's NVIDIA's GPU, so I'm not sure what we use.
We ordered, I don't know what we have.
We have what's the name of that? Sorry, it's just come out. Do you know the most popular one? The one for the games?
Oh, the GTX Titan.
Yeah, Titan. Yeah, Titan Black.
Okay.
We are using Titan Black, but I think we are ordering the K40.
Okay.
Yeah.
Right.
So it should be compatible. That we might need to look into a little more, like how to set up the GPU.
I see. So when you went, the hardware setup was done, or did you do that yourself?
I did it myself, but I don't remember exactly what it was. But
was it challenging? Like,
no, it's not that bad. It's just you just have to get another like repo and make kernels there or something. So I think it should be okay.
Okay.
We just have to go through that. But like the rest of the setup for just Neon itself is really simple. So I would recommend using a virtual environment. It's just better that way, keeps things clean. So these are the dependencies. Runs on Python 2.7. So the second one, libyaml, it's just if you want to use YAML files. I'll go through each one. So YAML files, they'll just mark down files. It makes things really easy. You don't even have to code. And you can build your whole network using that. And you use brewing stuff. Oh, I didn't write anything for like Windows.
No, well, I mean, that's fine.
Yeah.
I mean, you need some underlying library besides PyYAML, like the Python dependency?
The PyYAML?
PyYAML.
Yeah, I think that's fine.
Yeah.
You just need something to be able to read your YAML files.
Because Homebrew is not my favorite.
Oh, really?
It's okay, but I mean, if I don't have to use it.
Okay.
Yeah.
I use it for everything.
Oh, really?
Yeah. What do you use?
I use Homebrew when I have to, and I use Pip every other time.
Okay. Yeah, these ones have to.
Because somehow I have Bruise Python, some other Python, and I cannot get them to be the same. It's
Okay.
so hard to do that.
Yeah, and so when I install things on Brew, like I
Yeah.
put VTK on Brew,
Uh-huh.
that worked because VTK is like impossible to install.
Okay.
So I got it on Brew, and I can't get it in my actual Python.
Yeah, paths can be a
Yeah.
pain. Yeah.
But otherwise, Brew's good.
Okay, so
Okay.
so I used Brew for this stuff too.
Well, OpenCV, you better, right? Like that
Yeah.
one stuff.
Yeah, so those ones, you need these to, like, if you have a large image data set. So for example, with ImageNet, you're going to need this thing that I'll talk about later, and those have these dependencies. But for like a small image set, like CFAR10 or MNIST, you don't need this. So HDF5 is, if you want to see visualizations, that's just the data set format that they use. So current visualizations they graph like test and training error, and also like the all ConvNet visualizations that I had.
Mm-hmm.
Yeah, so you can use those. And then so I was saying the best ways to do a virtual environment. And then to get Neon, you just get it from the GitHub repository, and then you just make and activate the virtual environment, and that's it. Okay, so
sorry, have you guys used virtual environments before?
No.
Yeah.
okay,
It's really as easy
Yeah.
as just saying like.
so you just do pip install virtual env and then activate. So what's really nice about it is it keeps all your dependencies in one like folder. So when you're in that virtual environment, you can say you want to run Python 3, but you don't want it anywhere else. So you just use Python 3
Yeah.
there. Yeah.
And like in their requirements file, they say the specific version of each thing that they need, and so it will. If you don't use the virtual environment, it will reinstall your system. Whatever, like PyM or NumPy to something else, which may mess with your other stuff. So here, just install the dependencies in one place. So those versions are just there.
Right.
Yeah.
So if
it's
it
very
breaks, you
nice.
can just delete
And
it.
it's really as easy as she's saying. Like just those commands.
Yeah. So this way you'll have Neon on your computer. And then, so this happened to me. It didn't install properly. So I just literally just deleted it and ran make again, and it worked. So something weird happened, but.
Can you go back to the just the virtual env? I have virtual env. How do I activate?
Oh, you do
that?
.vmv when activate.
Two dots?
Yeah, it's dot and then space and then .vmv.
Oh,
yeah.
I see.
I always forget. You just have to remember every time you go in, you have to activate the virtual environment. Yeah.
Okay.
Yeah. And then to deactivate, you just type deactivate. Okay, cool. So then to run an example, you would just type one of these. So I can show you in how you would actually just do that. So I actually just installed this morning because I didn't have it on this computer. So, so it's really straightforward. And then you just go Python MNIST. Okay. Oh, see, I'm not in my virtual environment. Python. Okay. And then it's training. Yeah. So.
It's done.
Yeah.
It converged.
This is really fast.
Yeah. So that's how you run a model. So that one was the Python model, and then if you want to do it using YAML, then you just run neon and then MNIST the YAML file. So it's the same thing. It's just using YAML instead. Yeah, so it'll give you the same. Okay, and then, yeah, so if you want to run an example, usually, you want to specify, say, backend or whatever. These are the command line arguments that you can use. So like when you do Python mnist dot like py, then you go -b GPU if you run it on GPU and all these things. So how many epochs to run it? It's all command line arguments. So that's just all the different things you can use.
And their code is in Python.
It's all in Python, so you can read it.
We can actually just import some of, like, if you don't want to do command line, if you want to include it in a Python workflow, you can probably
you can just change it. Right, so you can actually just do it in here. So instead of saying, so right now it's taking in the arg parser, but you can just directly specify, okay, epoch is 5. Yeah. Yeah.
Cool.
So that's pretty straightforward. Okay, so this is how you, this is how you actually configure a model. So in YAML, you would just
increase the font size. I think it's Command plus.
Okay. So in YAML, you would just do this. You just pick your cost. It's literally just like markdown. So you just write whatever, like cost, epoch number, batch size. This is weights, type of initialization, Gaussian, and then you just specify your layers and you just list them.
So, okay, advanced topic, you can skip this until later, but so for some of the networks I'm doing, we have a very special way to select connections, like very sparse connections. In PyLearn 2, they have those. We could like define a new model and then in the mark, a new method, extender model, override a method, right, to select the connections and then call it from here. Do you know have you worked with that at all? Or
I'm not sure. What do you mean by the?
So like in the, let's say it's a 3-layer autoencoder, right? So the input to hidden layer, we don't want fully connected. We don't want a neighborhood. We want like a sparse subset of a neighborhood.
Okay.
With a specific number of connections. So probably like most frameworks, they'll allow you to do something like that. And so what we did is we actually extended the autoencoder object, and they have a function that, where they select the weights, and we overrode that function.
I see.
And then we could say, oh, well, this layer's, this new type.
Yeah.
Like
so I don't think they have that built in, but it is all written in Python, so you can modify like whatever you want. I think it's pretty easy to modify. Yeah. And then you just specify your data set. So
what were the stars and the ampersand?
The star is because you specified this is what I'm going to call weight init. So down here, when I call weight init, it's referencing this Gaussian that I specified
that
there.
would be the unit. The second one could be anything else, just a string.
Yeah, you can, whatever you want to name it. Yeah. Yeah. So if you want to look at, so that was YAML, and this is the Python version, which, I mean, I actually like using the Python one, but it's like the same thing. So these are all the possible layers. That's all in documentation. So you just specify batch size. Again, you can just specify your epoch number and everything you want here, like your backend, you can specify here and just ignore the arg parser. And then all you have to do is, so for CFA and MNIST, they have built-in load functions. They also have a built-in one for ImageNet. For other data sets, you can add your own. And it just has to be in this format. So it's just X, Y, and then the number of classes. yeah, so it's X, Y. So data iterator is a iterator that just goes over every data point. So you just have to pass it your X, Y, your number of classes, and your L shape, which is the number of channels, and then height and width. And then, yeah, so you just create a layers list and you just append whatever layers you want to it. So I think they still have this. So like you specify, one of the things that I find can be tricky sometimes is the weight and like the activation, it's thought of as a layer. So it's just treated as a layer object.
Yeah,
Yeah,
that's fine.
that is okay. Yeah.
Kind of, but I mean, it's not being appended directly to it's with the activations within the comp layer when you specify here, right? You know,
Yeah.
you're not yourself treating it like a layer. You know what I mean?
Yeah. So as the user, you're
Yeah,
not
I see.
treating it.
But
Yeah,
underneath the covers, they wind up doing that.
Yeah.
I see.
Yeah. Yeah, and then you just create the model. And so callbacks, there's a bunch of stuff like save, wait, there's stuff like that. And yeah.
Cool.
Yeah.
Oh, but do you load all the data set at the beginning of that line? Yeah. So that's all the data set. But if you're using, for example, ImageNet, I think that's incompatible.
Oh yeah. So for ImageNet, they do something different. ImageNet.
I mean, you can't tell from that, you know, whether they're loading it. You know what I mean? Whether they're loading it on the fly, or whether you know what I mean? They're just creating an iterator.
Yeah.
The covers.
They're
Could be doing
doing
anything.
that's batch size, I think. Oh, batch size is per batch.
Yeah. I guess when they're doing ImageNet, they're loading it inside.
Yeah. ImageNet is completely different.
My guess would be the data iterator kind of controls that behavior.
Yeah. So yeah, data iterator you can use, like I said, for any like smaller data set. It's easier. I think data iterator is really easy to understand. It is just going over the X's and Y's. But yeah, for ImageNet, they have this thing called Image Master. And let's see. Not sure where it was.
Oh, they have an AlexNet example.
Yeah. So these are all. They have a lot of examples here. Let's see. Oh wait, where's the AlexNet?
I mean, I'm just in GitHub and they have it there.
Oh yeah, they didn't. I think they didn't put it in here for some reason. Yeah. But
They have a GUI or something for this. I mean, at this level, it's more convenient if you have like a GUI and then you just drag and drop.
They should, but they don't have that yet. Yeah, they should just have like add these layers.
They want to give you like a feel of like you're programming and you're a programmer and you're actually doing.
Yeah.
You go to the GitHub account, and you go back to examples there. Yeah, the first one that AlexNet is.
Okay, cool.
Uses what you're actually talking about.
Okay.
Yeah, batch provider.
Image Master.
Yeah.
To try catch, I think up a little bit. Yeah.
Oh yeah, right. So Image Master is the thing that they made. It's like a server client sort of model, and it's just much better for like big data sets.
And I was going to ask about if they do the transformations to augment the class. Is that what the do transformations is? Do you think?
Do transforms?
Yeah. Oh, sorry, do transforms.
Wait, sorry. What is your?
So like Panchi was talking about, they did a lot of like translations and affine transforms to augment the data set. Do you think that's what?
I don't know if they automatically do it. This might be a different. I don't think they're talking about this yet.
Like random crop the original image, I guess. That's like the common approach. But I don't think I found transformation
Yeah, I don't think that's in there.
Oh, yeah, I found an issue. Issue 12.
Oh,
Augmentation.
okay. Yeah. So yeah, so if you just want to see like how to define the layers or the costs, it's all just under these sections here. So it's all just in the documentation. So these are all the layers you can define in your YAML or in your Python file. Yeah. So let's see what else. Yeah. So these are the data sets that they support. Like MNIST, CIFAR, and ImageNet, they have automatic loaders, and then the rest. I think there is a way to. Well, they have to like download it from somewhere, but yeah, it's those are all supported. And if you want to add your own, yeah, they only take image data right now for adding your own data, and you just pass in anything in the format, like in this compatible format. So the size of, like the number of examples you have and the size of your image, like channel times height times width. Yeah. Yeah, so that's what I was talking about earlier. Yeah, so the visualizations, they're not out. It'll come out on my account. And it is just one line at the end. So what you usually do for visualization is you don't want to save every epoch because that's just going to take a lot of time. So you just run it and then tell it to save on like the last epoch. So it does take a while, but if you're doing it on the last epoch, it doesn't really matter as much. Like the saving for guided backprop takes the same amount of time as training one epoch on ImageNet. Yeah. But once you have it, you have it. Yeah. So I think that.
What does it visualize? The gradients?
So right now you can visualize the training and test error graph. It'll just do that for you every epoch. You can also visualize the weights for like the first 3 layers and the thing I was talking about last week, the guided backpropagation, which works for all convolution nets. Yeah. Yeah. So.
Do you have any visualizations? Or I mean you showed.
Yeah, the ones I showed last time.
Cool.
Yeah.
Oh, is it possible to do recurrent neural networks with this?
Yeah,
Yes, they have
for
recurrent.
iOS, yeah.
Yeah. They have recurrent, yeah.
Oh, they even have LSTM.
Yeah.
LSTM. Yes. So what is it? Do you know what it is that's making their implementation? Because it's in Python, so it's not like they're going lower level. Do you know what it is about their implementation?
Well, there is like a back end, like a back end.
A back end.
Yeah, and there's a guy who's really, really good at kernels.
I see.
Yeah, so that's basically accounting for all the speed.
So does that mean that part of the installation requires compiling? Like when you install from GitHub, did you also have to run a make step?
Oh yeah.
Yeah. Okay,
Yeah.
I missed that one.
Yeah.
I see. Okay.
Mm-hmm. And that's what might require the max as.
Right. Okay.
Yeah.
Right. And just
that's
have
what
a really
make
good guy. Okay.
So it's not like fully open source, right? Their backend development is not there. So everything is there and everything is in Python, not C.
No. Some of the open sources, yeah, probably
Yeah.
plus.
So if I just be in there, I'll find some
I'm not sure. Yeah, he does. I think that guy does do
and
some
then they
low
could just
level.
provide the binary.
No, I mean, because
If they're
Let's see.
I mean, yeah.
What he's
Yeah.
doing.
piano isn't completely in Python. It's not as fast as Cafe.
Yeah, it's not like completely in Python. But I don't really. Yeah, that's the guy.
Scott Gray.
Yeah. So I think it's like his stuff that is really making it great.
Cool.
Yeah. So
Awesome. Thank you. So are you going to continue using this for your own stuff here, or are you going to continue with them? Or?
I'll probably use it for like the stuff I'm doing here now. Yeah. But I don't know, because I guess I'll probably add some more stuff to visualization. So if you guys want anything specific, I can start looking at it.
It would be good if you visualize in like 3D in real time. Using OpenGL, that would be awesome.
It would be, but it's
You
just.
love
It's, oh, nice. It would be, but the data is just. Yeah, I thought about that, but it's just that with a big thing like with ImageNet or something, there's so much data, like it would take so long. So like it's the trade-off of that.
Oh,
Yeah, you have to search.
You have to
for
go
all the
everything.
images.
Yeah. Yeah.
So, sorry, I missed I missed the very beginning. So, what's the motivation if you want to just stop using Cafe and use this one?
It's way faster.
It's way faster. So
I can show you the benchmarks. Oh, also, I spoke to one of the guys there, and he said that he has a script that can help move from Cafe over.
Oh yeah, that'd be really cool.
Yeah, and he said he could help with that. And he also has a script the other way if you want to compare models.
So the main issue right now is there's a compilation step.
So
Right,
Cafe is
so
all the
that
way
you-
down here for F prop and back prop. And this is neon up here.
That's 20 times.
So what's the Cafe native?
Cafe native, I'm not sure.
which data set is this?
This one was AlexNet. And then they have it for a bunch of other ones. So Cafe just doesn't perform as well, I guess.
And this is like the time for one iteration, like going.
This
back
is
or-
for one F prop, yeah.
So you have all the functions that Cafe has.
I don't know.
So,
I don't know the
Yeah,
Cafe
so-
functions. But
She can send out the slides, and we actually recorded, so you can go back and check. But the only issue, I mean, you can run it on CPU to play around with it.
but CPU is not that good.
Yeah, CPU is not that good. The GPU step, whether they can compile it on our current graphics card, we don't know, right?
Yeah.
So
I think you can.
Oh, this
Yeah.
is
We think
For-
so, but
only one
Have to
GPU,
check.
or does it support multiple GPUs?
I think it's currently one GPU.
One GPU.
Yeah. Yeah. But they're working on multiple. Yeah.
cool. Okay. Thank you.
Thank you.
So yeah, so I set up a Guru YouTube account, and so we didn't hang out on air for this one, so it'll be posted there. So you go back, and then Angel, do you mind like making your slides into PDF and
Oh yeah, sure.
sending those?
Yeah.
Yeah. Yeah, it was pretty straightforward, right?
Yeah, it's
Yeah.
pretty
Kind of
simple.
play with it. Okay, so did you just hang out down there? Can you go to like window I think you minimized the
Window.
in the Hangout.
Oh, there it is. Yeah, I couldn't find it.
And then you